Hi, I'm Bob Rich. Uh, I'm a professor of medicine at the University of Alabama at Birmingham, previously dean of the School of Medicine at that university. I got into immunology really when I was a medical student, and it actually came from my undergraduate research experiences where I was interested in the differentiation of cells, how cells took on a certain kind of life. And it was at the time that Dick Dutton, who's here at this meeting, and Bob Michel had described a way to understand the differentiation of B lymphocytes in a test tube in vitro. And I thought, that's really cool. And as a consequence, I thought, well, I can understand cellular differentiation if I study the kinds of things that they're doing. So I just went and saw an immunologist at my medical school and said, I'm interested in cellular differentiation, and it seems to me that immunology is a good way to study that because you can get your hands right on the cells. And as a consequence, I spent a whole career doing it. The first scientific meeting that I attended actually was not an AAI meeting. It was at the time when FASB was the entire body, and I was a college student, and I presented my senior work on cellular differentiation there. So it got me off to a start as a college student that then led to the story I just told you about, which is cellular differentiation and by reference or by extension, immunology. And that was in 1961 or 2, long time ago. The best piece of advice I did not take was probably, you could be assured of a real career if you went out and practiced medicine. That's a much better, a much more assured career, and in particular, you don't need to worry about where the next grant's coming from. People will always be getting sick, and they will always be needing doctors. I didn't take the advice. My biggest disappointment, I suppose, was at a time when I was working on regulation of the immune response with something called suppressor cells. And for reasons that had nothing to do at all with what I was working on, suppressor cells developed a bad name. And they went away for a decade. And now they're roaring back, except because of this because of this previous stigma. Now they're called regulatory cells. They're the same cells, and they do important things. And so I was vindicated in the end, but it was a disappointment of a career. I mean, a disappointment of a decade or so when I thought I had done something and was working on something right, and then it was dismissed for a while. And by the time it came back, people had sort of forgotten about the work that we'd done previously. And my most influential person in science was my wife. We met together in a laboratory at Harvard School of Medicine, and we collaborated for a good number of years. We've gone our separate ways scientifically, and we both ended up being administrators, but I think we both had mutual influences that surpassed all the others. Well, the most influence on me personally, which is very different from what is the technology that's available today, was, as I started with this discussion, the capacity to actually study the development of antibodies in a test tube, except it wasn't really a test tube, it was an open flat plate, a petri dish. That technology was very valuable to me in getting me started in my early successes. And then I think the second technology, which is still very much a part of modern technology, is flow cytometry. Flow cytometry basically revolutionized flow cytometry and monoclonal antibodies. Those two technologies stand head and shoulders, I think, in terms of the specific technologies of immunology as compared with all of molecular biology. Flow cytometry and monoclonal antibodies have a particular role in really defining modern immunology. What I tried to impart on my mentees, the most important thing was personal integrity. of basically understanding what is right, understanding that it's not expected that every uh, experiment turns out the way you'd like it to turn out, or that it's always successful, but that you get it right. And if you get it right, ultimately, you'll be rewarded by success. What brings a joy is the joy of science. It's the pleasure of being able to discover new things, to find new things, and to work with people who are doing it themselves, and to enjoy with them their discoveries and their pleasures.